The first thing is that I want you to understand that there's really two approaches. They're the same because when I graph this here, when I graph, let's just do the sine first. When I graph that, okay, the arc sine or the sine inverse, that is the same thing as this over here, okay? But the ordered pairs over here are just these y values, comma then these angle measurements. Does that make sense? But it's the same information that's coming out of or providing both these things. Okay, so that is, like I said, that is the sine inverse, and I'm going to jump back and forth because I think it's important for you to see this and deal with this way. But I'll jump back and forth between that notation and that notation because that's usually what textbooks do. Okay, they will periodically use both versions. I don't know if maybe be on the lookout on the ACT juniors when you take it. Was that Tuesday? They might use that. They might use that notation. Okay, just kind of an author thing. Okay, depending on how that author is accustomed to doing it. But the questions are that we're going to be seeing here. I think people like to view it this way, but I think some people also like to view it this way. So I want to talk about the kind of the correlation between the two. So you're going to see things like this. It's going to say sine inverse of 1/2 is equal to what? Okay? And then we have to go figure out what that is. Okay? So if I'm looking at it as a graphical approach, okay, I'm thinking, maybe we can think about it this way, write it as maybe an equation, because we are in the x and y axes, right? And this essentially is the x value. Okay, so let's say that I put x here. Okay, so obviously here's your x-axis, here's your y-axis. If I say x is 1/2, okay, so that's my input. I go x is 1/2, so I'm right here. What is the y value on my curve that would be spit back when x was 1/2? Pi over 6. Okay? Does that kind of make sense on the process of doing that? It's just like any other question, any other function that we've ever dealt with. I say y equals x squared, and I say, okay, if x is 2, we go to 2 on the x-axis and see what the y value is on that curve at the value of 2, right? And we know that would be 4. Okay? So it's the same thing. I just think people get crossed up because it's notation. We haven't seen this very often or used it very often, and it confuses them. Okay? What if I say sine inverse of 1? What do I get back there? Yeah, pi over 2. Okay? Go to the 1, come up here. The y value that's stuck to that point is pi over 2. Okay? What if I say sine inverse of -3/2? What's -3/2? -1.5, right? So I'm going to take that -1.5 and I'm going to see, where do I cross my green curve? Never. So what do we say? It's undefined. Good. Okay. Is that doable for everybody? What are the only output values that you're ever going to get? What do they exist between? My outputs are my y's, right? So those are the only y values that you're going to get back. -pi over 2 to pi over 2. Okay? All right, so is everybody okay looking at it graphically like this? Let's answer the exact same questions, but answer them over here. Okay? And the answer to what you just told me about -pi over 2 to pi over 2 tells me that on the unit circle, I should only be dealing with that stuff there. Okay? Because here's 0 to pi over 2, right? And this would be -pi over 6. This here is -pi over 4. -pi over 3. -pi over 2. So now the question is, can I find sine inverse? We already did sine inverse of 1/2, and you told me that gave me back pi over 6, right? can you see how we do that over here in the unit circle is, let's just draw a couple comparisons of what we've done in the past. I'm just going to put y here. That there is an angle, right? And when I evaluate sine at an angle, don't you get a ratio back? Okay. Well, when I do the inverse, don't the inputs and outputs change? So now I'm inputting a ratio here, and it should spit back the angle that's attached to that ratio, correct? Well, because I'm talking about the sine, I know that should be the y value off the unit circle, right? So essentially, I'm coming over here on, now it's only between negative pi over 2 and pi over 2, because that's only angles that can be spit back because of what this curve is telling me. So I'm going to use the unit circle to do this. Let's say, okay, find the y value of 1/2 inside this semicircle. Okay, so I go through. I think it might be good to just kind of visually see just what my y values are. I'm looking at all these y values, and I'm going to pick off the one that is a positive 1/2. All right, so we see the one that's a positive 1/2 right here, right? Okay. Now work yourself back into the circle. What angle is that attached to? Pi over 6, which we knew that looking at this, right? So you see the kind of the two different perspectives you can use to evaluate these things. Okay. If I said, what is the sine? And this is where some people sometimes get themselves in trouble on some of the stuff that we're going to do later. If I said, what is the sine inverse of negative radical 2 over 2? I'm going to be looking at my unit circle in the first and fourth quadrants. There's my negative radical 2 over 2, right? What is the angle that goes with that? Negative pi over 4. Okay. Now we're accustomed to that word pair. They gave me that y value of negative radical 2 over 2. We're accustomed to calling it 7 pi over 4, aren't we? Okay. But is 7 pi over 4 on that green graph on the right? No. 7 pi over 4, guys, is well beyond pi over 2, right? Pi over 2 is about 1.57. 7 pi over 4 is probably in the ballpark of 5 something. Okay? So it's a y value that is not on that green curve. So that's why we have to view it as a negative pi over 4. Does that make sense? Okay. And if we use a calculator, using the sine inverse, and I said negative square root of 2 over 2. It's giving me that value right there, which that is negative pi divided by 4. Is that okay with everyone? Okay. One thing to pay attention to with Desmos, if you guys use this, let's see what I did there. Click on this cog here, and you can delete all. But that kind of just resets everything, as if you just open the applet for the first time. So let me show you what happens here. If I'm in degrees, okay, and do something, and then go delete all, what did it default me back to? Radians. Okay, so that's just something to think about if you use this calculator. It's something we ran into the other day in my geometry class that some students were struggling with. Is this something we can do with the sine? Okay, so now let's look at the cosine. So if I graph the arc cosine of x, gives me that thing there. Okay. What is the domain of this? Negative 1 to 1. What is the range? 0 to pi. Okay, so now when I'm asked questions about, cosine inverse, let's say of, I don't know, let's just go 1/2 here, make it easy first. This is my domain. That's my input value. So that number has to be between negative 1 and 1. Okay? And this number that I get back, my output, has to be between 0 and pi, right? So if I'm drawing the correlation to the unit circle, now I can only look, let me just do this. Let's make it. Now I'm only looking at that blue portion of the unit circle, right? Because those are the radian values of 0 to pi. All right? So when you say cosine inverse of 1/2 coming over here, cosine of 1/2, cosine inverse of 1/2, find 1/2, go up my curve, and what's that angle it spits back? Pi over 3. Okay? But if I'm over here, okay, using the unit circle approach, I'm going to go find the x value of 1/2, because cosine is the x values, right? I find that, and now I work back to the angle or the arc length, and is it pi over 3? Yeah. Okay. What if I asked cosine inverse of negative radical 3 over 2? Negative radical 3 over 2. It's a little bit harder over here because my x-axis is not written in regards to radicals, right? Okay, I just got my rational numbers down here identified, but if I find, this is the easiest way on, and you can do this on Desmos or you can do it on GeoGebra, to kind of find that y value, I would type in x equals negative square root of 3. It'd be nice if you see what I'm typing. I'm actually typing nothing. X equals negative square root of 3 over 2. So now I'm looking for the place on the y-axis that I get that point right there, right? Does that kind of make sense with everybody? Okay. And that point is, that y value is 5 pi over 6. So this answer would be 5 pi over 6. Hopefully you see it. That's actually a little bit easier to answer if I understand the concept of the unit circle. My x value is negative radical 3 over 2, so I'm going to go find negative radical 3 over 2. It's right there. What's the angle attached to that? 5 pi over 6. Okay? So you might be a person that says there are some times when it's convenient to use this, and sometimes it's convenient to use this. My hopes are that you learn this well enough and that you deal with this enough that you understand that they're kind of synonymous. They're the same ultimately. Okay? And that you can use one over the other kind of interchangeably. Okay? Is that doable? All right, now that's the cosine, and we're going to come back and we're going to do some more elaborate questions here once we've talked about the tangent function as well. But I think I made, and Chris brought this up yesterday at the end of class, I made a mistake yesterday when we wrote down the range and domain for the tangent function, okay? Because if I just graph, let's just graph the tangent function that we are going to use to find the inverse. Okay, so that is the tangent function, the portion of it that we use to find the inverse, right? Okay, where are the asymptotes located on that tangent function? That's the parent tangent function. Okay, so there's one at pi over 2 and one at negative pi over 2, right? Okay. And understand that those are part of your graph, right? Asymptotes are I don't know the best way to articulate this, but I mean, they're not points on your graph, but they're boundaries that you have to use for your graph. Does that make sense? So when I reflect this thing over the line y equals x to find the inverse, those boundaries should also reflect as well. Okay? So when I'm just going to put it gets kind of ugly here, but just going to bear with me. There's my line y equals x, right? So if I'm going to reflect this blue curve over that line, well, the thing that is confining and providing boundaries for that blue curve are those asymptotes. So we're going to want to flip those over that line as well. So when a vertical line is flipped over the line y equals x, it becomes a horizontal line. Okay, so now let me just clear some stuff up here. Okay. So that then provides us the tangent inverse, correct? Okay. So this is over here, y equals either, you want to write this way, tangent inverse of x, or y equals arc tangent of x. When I look at this curve, think about your domain values. Domain values. What are the things I'm allowed to put in here? All real numbers. Okay. And last class I kind of showed them something here that will kind of see if I can mimic for you guys. So the domain is all real numbers. But the range, what the range is going to be, what are the y values I can use here? What's the lowest y value based on this graph that you're going to have? Okay, negative pi over 2. But will I ever get to a y value of negative pi over 2? No. Yesterday, I think I put brackets on that, square ones. Okay? It needs to be a parenthesis. Same thing on the top one. Okay? For the reason that, let's see here. Let me actually open another program real quick. And on GeoGebra or Desmos, I can only go out to, even if you're on your TI 3 or 4, you can only go out to 10 to 15 decimal places. Okay? But this program does a little bit more than that. So what I've done here, guys, this is just the tangent inverse of looking at the x-axis here. Obviously, I just found the tangent inverse of 10. So I try to go to 10 and see what is the y value that I get stuck with there. Does that make sense? Okay. Now, if I go out to 20 decimal places, it's going to be that number there. Okay. But what if I do 11? This is dumb. All right. Maybe that's better. Is that all right? Can you guys see this blue number a little bit better now? If I go out to 11 as my x input, okay, that's great. That's a good number. But if I go out to, I don't know, 100 on the x-axis, okay, I get that number, okay? Or if I go out to, let's say, 1,000, I get that number, right? Okay. Now, my question is that close to pi over 2? And let's go 20 decimal places for pi over 2. Okay. We see that these things are pretty, I believe, to that 2 right there and that 2 right there where my cursor is, they're the same, right? Okay. But after that, this one is a larger value. The question is, will I ever be able to get these two things to be the same? Well, if I go out to enough decimal places here, Now you get 2, 6, 7, 9, 4, 8, 9, 6, 6, 1. So now I'm down to this last decimal place being the same, right? Okay. And maybe I put in another, and I evaluate, and now they're the same, right? So that view looks like these two things are the same, right? And I've evaluated the arctangent at a big enough value that I get an x value, or sorry, a y value that is exactly pi over 2. But I'm only showing 20 decimals. Okay? If I show 20,000 decimals, okay, that value right there, and I don't know if I can, all right, so I'm going to do something probably nobody would try. That word. Okay, let's see here. I'm just trying to cut this, so cut this decimal place out, this 20,000 decimal places, and then search inside here for that decimal place. So I don't know if it'll work. Find next. There it is. Find next. Okay. So I think it did work. No. What I'm trying to show you, we'll zoom out here and make it a little bit easier, is that decimal place there. All those decimal places there are smaller than this one. Is that all right? And I don't know. Maybe we can do this. Let's see here. Eval F. Let's do that minus eval F of pi divided by 2, comma 2, 0, 0, 0, 0. So we get this number here, okay, which would be point and then 7 zeros and then a 1, right? Okay. So we're seeing that if I subtract those two values, we do get discrepancy. They're not the same. Does that make sense, everybody? Okay. So just trying to prove to you, I guess, in a different light, that when we write the range here, we never get to pi over 2. We never get to negative pi over 2. Okay. So if that's the case, then if I want to use, I can ask you guys what's the tangent inverse. Now, it's kind of a pain in the butt using either one of these approaches because of the way we set up our axes. But if I say what is the tangent inverse of an x input, so I'm looking for like 1/2, okay? I'm going to look over here. I'm going to find the line x equals 1/2. And now try to find what is the y value on that curve of 1/2, okay? Does that make sense, everybody? Okay. Now, how do I do that over here? Okay, and actually, just to let's do it this way. Instead of saying 1/2, let's go like, because these are the kind of numbers you're going to see. If I say radical 3, tangent inverse of radical 3. So we would say x equals square root of 3. Okay, and now we're going to try to figure out what is the y value that goes with that. Well, looking over, it looks like pi over 3, right? So tangent inverse of tangent inverse of radical 3 looks to us like it should be pi over 3. And I just want to check real quick arctangent of square root of 3. Is that pi over 3? Yes, it is. Okay. So how can I do that on the unit circle? Well, we have to decide where do we look on the unit circle first of all. My range is between negative pi over 2 and pi over 2, right? Okay. So those are the output values. So when I look at the unit circle, the only thing that I'm going to be interested in then is going to be that blue stuff off the unit circle. Okay, those are the quadrants that I'm going to use. And that's the same set of quadrants that we use for the sine, right? Okay, but now when I look at this, and again, we would want, because it's negative pi over 2 to pi over 2, we would want this to be written as negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. But as we look at this, the values are not showing up as radical 3 over 3 or radical 3 and stuff like that. Because this is just the sine and cosine information, right? In our unit circle, and we've talked about this, we don't have the tangent information because, quite frankly, there's not really enough room here to put that in there. And if we needed it, we can always go through and do the algebra, I think, quickly. We know right there that 1 divided by 0 is undefined. Negative 1 divided by 0 is undefined there. And that's why we don't get, that's why these asymptotes exist where they do. Right here at 0, we're going to have 0 divided by 1, which is a 0, right? So right now I'm just writing all the tangent values down. Right here, what's the tangent value at pi over 4 going to be? 1. What's it going to be at 7 pi over 4? Or which we say is negative pi over 4. It's negative 1. What about right here? Okay, now we got to do a little bit of work here, right? If I go 1/2 divided by radical 3 over 2 real quick, doesn't that give me 1 over radical 3? The denominators cancel. And that rationalized is radical 3 over 3. So this tangent value is radical 3 over 3. What's this one going to be? Negative radical 3 over 3. Okay. This one up here, radical 3 over 2 divided by 1/2. What's going to happen with the denominators of 2? Yeah, they're going to cancel out, leaving me just radical 3. What's this one down here going to be? Negative radical 3. So there are my tangent values. Okay. So if I ask you what is the tangent inverse now of radical 3 over 3, you find radical 3 over 3, and now you look at the angle that's associated with that, it would be pi over 6. Okay? And when I ask Desmos, arctangent of radical 3 over 3 gives me that number there. Is that pi over 6? 0.523, right? Okay. When we ask what is the, we can go tangent inverse of negative root 3 over 3. Sorry, just negative root 3. Negative root 3, that's right there, right? What's the angle that goes with that? And it should be negative pi over 3. Okay? Because of how we've got, I erased it, but we should have that 5 pi over 3 written as negative pi over 3, right? Is that something we can do? All right, so here's the thing, and this is what people want to do, but I want to caution you against it, is when we see questions, I'm going to go back to the sine function just because it's kind of fundamentally a little bit easier to deal with than the tangent because of what we see on the tangent curve and how those roots and everything, radical 3 over 3, and that stuff shows up. But let's just deal with the sine inverse. When I ask a question like this, if I say sine inverse of sine of pi over 6, and I think we've done this before. We've done maybe one of these earlier in the week. If I ask you what that is, this is a composite function. You guys remember doing this like f of g of x, that kind of stuff? That's all we're doing here. Where g is your sine function, and f is your inverse sine function, right? If you remember how we did these, we evaluate from the inside out. So what we're going to do is we're going to look at this thing right here and evaluate that, okay? So if I'm thinking about the unit circle, I think that's maybe the best thing to do here. If I'm looking at pi over 6, what's the sine value that goes with that? 1/2, okay? So that changes to 1/2, but it's still now, it's still the argument of sine inverse, isn't it? So now I got a new question. Now I'm going to ask myself, what is the sine inverse of 1/2? Well, now I'm going to go around the unit circle looking for y values of 1/2 and work my way back into the angle that is provided from. So here's my y value of 1/2, right? What's the angle that is provided? Pi over 6 or 30 degrees, right? So we do that enough. We do that practice enough with numbers like pi over 6, pi over 3, pi over 4, okay? Negative pi over 6. Essentially, if we do that with the radian measurements that are inside that blue region, we can end up making the argument that, well, sine inverse and sine just cancel each other out. You're left with just the pi over 6, right? Does that make sense, everybody? So a lot of people, and this is where I want to caution you, because yes, you can do this. You can say, oh, those are inverses, they undo each other, and I'm left with just that value there as an answer. And if you do enough of them, for instance, if I go sine inverse, do another one real quick, sine inverse of sine of, let's go, negative pi over 3. Okay? Well, sine inverse of negative pi, remember negative pi over 3 is that one right there. And there's the order pair that goes with it. So I would say, well, that's sine inverse of negative radical 3 over 2. Well, now I find negative radical 3 over 2 as the y value, and what angle does that get paired up with? Negative pi over 3. So we get that, right? And if we, even using Desmos, we can do this, okay? We can say, I'm looking for the sine inverse of, let's say, what did we do the first time? Pi over 6? I get that. Is that pi over 6? Yeah. Okay, so we're saying that these two things just canceled out. But now here's my question. Does that happen when I go sine inverse of sine of 5 pi over 6? Okay. What is the sine of 5 pi over 6? Think about the entire unit circle. Yeah. 5 pi over 6, its y value is this 1/2, right? So now, sine inverse of 1/2. So that thing right there changes to 1/2, right? What's the sine inverse of 1/2? Pi over 6. Because remember, the sine inverse is never going to give you the stuff in these two quadrants, right? It's never going to give you 5 pi over 6 because this curve right here doesn't go to 5 pi over 6. 5 pi over 6 is up here, right? That red curve does not have that y value. So this is going to spit back just pi over 6. And there you're seeing that if you're a person that just thinks that these things cancel each other out all the time, you would be wrong, right? And even if I type this into my calculator, so this is 5 pi over 6, okay? You see how it's still giving us pi over 6 as an answer? Because 5 pi over 6 would look like this. 5 pi over 6 is 2.6, okay? Now, there should be some type of argument that we can make that allows us to know when cancellation occurs and when cancellation doesn't occur. Any problems like this, when I have sine inverse as the outer function, if I look at that radian measure on the inner function, and it's between negative pi over 2 and pi over 2, they cancel. You can use that. You can just pull out that argument and say that's my answer. Okay? But looking at 5 pi over 6, is that between negative pi over 2 and positive pi over 2? Is that in the blue? No, 5 pi over 6 is not in the blue. So when that happens, you have to actually do the calculations. You have to work inside out. Does that make sense? I think the safest thing right now for you, because I think there's a lot to think about there and a lot to remember when you can do it, when cancellation doesn't work. Safest thing to do, always just work inside out. You guys should know the unit circle, I think, well enough by now that you can quickly say sine 5 pi over 6, rewrite this question into sine inverse 1/2, and go from there. Okay. And the same thing happens with cosine. So if and it happens with tangent as well. So if I go, cosine, let's look at that graph first. Or cosine of x, okay? So if I say, what is the cosine inverse of cosine pi over 6? It's an easy one, okay? What is, so we're on cosine inverse. What's cosine of pi over 6? It's radical 3 over 2, good. And now I ask the question, okay, what is cosine inverse of radical 3 over 2? What's the angle that goes with that? Pi over 6. So there we see a situation where those canceled, right? But let's see a situation where they don't cancel. If I go cosine inverse of cosine of, let's say, 7 pi over 6. What's the cosine of 7 pi over 6? So I get negative radical 3 over 2, right? Okay. Now what's the cosine inverse of negative radical 3 over 2? Now think about where cosine inverse, cosine's only going to give me values back between 0 and pi, right? So right now we're looking at just that red region, correct? Does that make sense to everybody? So in that red region, what is the value, what is the angle that the x value is negative radical 3 over 2? 5 pi over 6. So did these two things just cancel? No. Okay. And that's something you got to think about. When will they cancel? Where was? Yeah. When will these cancel? What this value here was between 0 and pi, wasn't it? Should be brackets there. Is this number outside that? Yeah. Okay. And that's the thing. If that number, and it's for the sine, it's for the cosine, it's for the tangent inverses, if that number, as that inner argument, is within the range, within the output values of your cosine inverse, then cancellation occurs. If it's outside that range, 7 pi over 6 is outside cosine's range, okay? Then cancellation does not occur, and you have to do the evaluation process. Okay? Safest thing to do, get stuck in some situation or some point, and you're not sure, work it out. Go inside out, evaluate, replace, and you can keep doing it. On Tuesday, juniors, pay attention to the end of that ACT. Potentially, just in the past, I know the last 2 or 3 questions, a lot of times we'll use the inverse function, okay? And ask you questions about them, and ask you rules about, several that I've seen are more not evaluating like this, but they're like rule type questions about are these things equivalent or something like that. Can I say cosine inverse of cosine of x is x when x is bigger than pi? No, I can't. Okay, but if it's between 0 and pi, yes, I can. Okay, so you might ask a question that kind of relates to that. I don't think I told the last period this, but I'll move 6-4. Some people would ask for a little bit more time on that. I can do that. So I'll move that through the weekend. 6-5 is due next week at some point. I do hope to have those. You guys have those assignments wrapped up here pretty soon, maybe by Monday or Tuesday. 6-4 and 6-5. 6-5 is just a bunch of those questions we just did. I think it's like 30 of them. But some of them, if you pay attention to the rules, some of them you can answer just like that. Okay? Others you have to know all the time. Next week we're gonna start chapter 7. Okay? So Zach, put on your algebra boots. Okay? We're gonna use our algebra skills, refine them. We're gonna deal with trigonometry, but I think the big payoff, the big byproduct of what we're about to do for about a month is that your algebra skills are going to get a lot better, hopefully. Okay? Because we're gonna kind of stop using numbers and use these identities, and I think it helps you realize the things that you're allowed to do and the things you're not allowed to do in algebra. So that's the plan for next week. Have a great weekend.
You have a better weekend.
Well, thank you.